All right, guys. So one of the better, I'll say, applications of mixed and random effects, or mixed effects models, or the idea of random effects is longitudinal studies and repeated measures. Repeated measures are exactly what they sound like. We're just going to take the same measurement on the same person, or measurements on the same person. And longitudinal studies just mean we're going to do it over a period of time. So think about growth studies. Think about we're going to chart a patient and their reaction to chemo, or we're going to calculate, their white cell count or their red cell count over X amount of treatments, and then we're going to say this is a treatment. So if you think about a case like that, the let's say you're going to measure a cell count based on a type of therapy given to a patient, and you're going to give it to a bunch of different people. There's an effect for think of it as the time, that's a random effect, but there's also an effect for the treatment. The treatment we can treat as a fixed effect because we can randomly assign, we can do those things. It's placebo studies. It's really how the FDA gets around a lot of different things. From my perspective, this is one of the more interesting applications of it, so I wanted to show it to you. The first thing we're going to do is we're going to discuss a longitudinal study. It comes from your textbook. It comes from the Fairway book. I really like the examples they use. I really like the fact that the R code's in there. You're going to see a lot of the R code I choose to use here is the same, just because the way he talks about it, I think it's very clear and it's very applied in manner. He doesn't get caught up on all the theoretical stuff, though we do talk about the variation or do talk about the variances and stuff like that. You need to understand that to understand where we're really heading with this. Now, if you notice through the theory of this, what you're going to see is there's not a huge difference between random effects or mixed effects models and accounting for repeated measures. So this is the panel study of income dynamics. We're going to look at a subset of the data. We're going to look at 85 households who had complete data between 1968 and 1990. We have information about annual income, gender, education, and age. We're going to look at fitting a person based on the year it was recorded. So what we're going to do is we're going to center the predictor at 1978, and we're just going to fit log income. Basically what this is going to do, it's going to fit a model just based on year to see how income looks at year given person. If we do LM list, what this is going to do is it's going to fit a linear model for each person based on 1978. And if we do this, and I show you the first 10 rows, for the first 10 people, here's the intercept and here's the slope over time. So you would be able to plot this, and there's some interesting plots in your book. We didn't have time to get into all the ggplot stuff he does, though I will post some notes for you on that so you can start to understand ggplot and all the different things. I know data viz isn't until the last class, but it's something you could try and understand fairly easily, I think, with panel plots and things like that. So here's just a glance at the first 10, but what this is going to do is give you the slope and the intercept for 85 people given the person. So you've already accounted for the person. Basically, you fit an individual intercept and slope. Now, this is called a response feature analysis, and it doesn't allow us to use a ton of information because there's some things that will never change. For instance, gender would never change across this, so it's hard to get a gender effect. Education may or may not change. Age would change by one, right? It would mimic year, so it would be confounded with year. You'd never understand, even if you could get an estimation, because my guess is it's more than a guess. They're highly correlated. Matter of fact, they're perfectly correlated. If year goes up, age goes up. If year goes up, age goes up, and so on and so forth. So let's assume right now we want to understand income using sex, year, and education. And what we're going to do is we're going to fit a model that looks a little bit different here. What it's going to do is we're going to fit a centered year. So I'm going to call it PSID-C year, which is just year minus 78. Basically, what that's going to do is center the year. We're going to fit a response of log income. We're going to use year and sex interaction plus age plus education plus C year given a person. Now, why does this age not confound with year? Well, because you're going to have people at many different ages given a same year, so it's not going to confound as much. You're going to be able to get an age effect out of it. So we're going to fit a random slope for given a person for each year. So when we look at this, if I go through, we start fitting the model, and we look at the summary of M4, you take a look at some things here. The first thing you're going to see is here's all your fixed effects. So here's how it's going to come across with the fixed effects. You got a coefficient estimate, you got a coefficient standard error. Just if you just think about the fixed effects section, this is your linear model. But if you come down here and you start looking at random effects, well, we see the random effects, the intercept has a standard deviation of 0.53, which is high comparatively to the rest of these standard errors. But if you look at C year, we see it's fairly small, 0.05, and we get an interclass correlation, which is 0.19, basically meaning the relationship between the residuals and the random effects. So there's not much variation based on the slope. Now, what this is going to allow you to do, again, this is just a fixed effects model. We still used LMER. It's just the way we've accounted for the repeated measures. We're conditioning on person. We're saying we need to create a correlation structure based on this person, okay? So these are the type of things I want you to think about. These are the type of things we're going to deal with as we move forward. So you could test this. You could test, do you need CY year? Or CY year. Do you need the centered year slope? You know, you could do all this stuff using log likelihood models that we talked about in the last section. But moving forward, this is kind of how I want you to think of longitudinal studies. They're just mixed effects models, okay? That's part of the reason I'm showing you this. I know I didn't show you a ton of examples when we were talking about it, but that's because repeated measures in longitudinal studies are examples of mixed effects models, okay? All right, guys, let me know if you need anything. Let me know if you have any questions.